All attendees are in listen-only mode.
Hello, everyone, and thank you for joining us today for this special Tuesday edition of our HUD Water Wednesdays webinar series. I'm Laura Wetzel, a contractor for EPA's WaterSense program, and I'll be serving as the moderator for today's call. Designing landscapes to hold water on site has the dual benefit of reducing the need for supplemental irrigation and reducing runoff that can cause flooding and impair water quality. Today, EPA will talk about tools to help property managers integrate green infrastructure into their developments. Daniel Ransom of Tucson Water will provide an overview of the agency's rainwater harvesting rebate program, including initiative working with low-income residents to install and maintain passive earthworks systems. Neil Shapiro of the City of Santa Monica's Office of Sustainability and the Environment will discuss how their city is implementing an innovative rainwater harvesting system in their new public library, as well as a green parking lot. Finally, Andy Lipkiss of Tree People will discuss Elmer Avenue, a neighborhood in Los Angeles' northeast San Fernando Valley that was transformed from a flood hazard zone into a model of sustainability. So first, a few housekeeping items. To avoid disruption during the webinar, all attendees are muted. But if you have comments or questions during the webinar, please do add them to the chat box you see on your screen in the GoToWebinar panel. We will have time for questions following all of the presenters during the webinar, and we'll also respond to any questions that we don't get to directly. We know that people are busy and may not have had time to attend today, so we will be recording the webinar and posting it to the WaterSense website 2 to 3 weeks after the call. You'll be able to find recordings of previous webinars and registration links to future webinars on the web page you see on the screen now. Before we dive into our green infrastructure discussion, first we have a little poll to get a sense of how many of you are new to this series on the call today. So have we met? Yes, I attended one of the earlier live webinars. Kind of. I watched one of the recording webinars, or no, this is my first time. So we'll wait just a moment and then we'll show that information back out to you. So it looks like about 2/3 of you, this is your first time, and a quarter of you are joining us. I'm sorry, 2/3 of you, yes, and a quarter of you are repeat watchers, and then a small percent of you have also viewed one of our recorded webinars. So thanks for letting us know. So now let's find out who will be speaking today. Today's presenters are Charlotte Ely, Daniel Ransom, Neil Shapiro, and Andy Lipkiss. Charlotte Ely is a life scientist with the US EPA. She works for the Sustainable Water Infrastructure Program, providing technical support and financial resources to help communities become more water and energy efficient. She is the WaterSense liaison for the Pacific Southwestern Regional Office. Daniel Ransom is the Water Conservation Program Manager for Tucson Water. Daniel previously was the Water Conservation Manager for Sangre de Cristo Water in Santa Fe, New Mexico, and his current job duties include planning, policy, program development, and implementation, as well as data analysis, education, and outreach, all for the city's water customers. Next, we'll hear from Neil Shapiro, and Mr. Shapiro is the Senior Sustainability Analyst and Watershed Management Coordinator for the City of Santa Monica's Office of Sustainability and the Environment. He oversees watershed management programs, all of which are geared to reduce water pollution and use our precious limited water resources in a sustainable manner. And finally, we'll hear from Andy Lipkiss of Tree People. Andy founded the nonprofit organization Tree People at age 18 in 1973 and serves as its president today. Under Andy's leadership, Tree People brings together people, trees, and forest-inspired infrastructure to protect cities against droughts and floods, prevent water and air pollution, and mitigate and adapt to climate change. Without further ado, I'd like to now turn over the presentation to Charlotte from EPA. Charlotte?
Thank you, Laura. For those of you who have been on previous calls, this will be a refresher of the big picture that we talked about in the first webinar. First, saving water also helps to save energy. Water efficiency is important from a pollution reduction perspective and a cost savings perspective. If you reduce hot water use, you'll not only reduce your water and sewer bills, but also your energy bill. We also know that the cost of water and sewer services are going to increase. Although water is still pretty cheap, rate increases have continuously outpaced inflation, and rate structures are changing to drive more efficient use of water. So saving water can moderate the impact of rate increases. The U.S. population will continue to grow, and water resources will come under added pressure to meet human energy and agricultural needs. We know that climate change, too, can throw a wrench onto the availability of water, whether it be too much or too little. The weather news galvanizing attention these days is the continuing drought in the western part of the country. As you can see on the map, the drought is ongoing. The darker the color, the more exceptional the drought. For those in the West, talk of an El Nino is raising hopes that rains this winter may alleviate the drought. I would caution all not to let wishful thinking get in the way of staying the course and improving efficiency. It will take a lot of rain to fill reservoirs and even more to help groundwater resources recover. Finally, we know that there are opportunities to use water more efficiently in the multifamily sector, and we are very grateful to be working with HUD to get the word out. Next slide, please. Because this webinar is hosted by WaterSense, and since some of you may be new here, this is just a quick reminder of what we are. Our program was launched in 2006 to respond to the challenges on the left by developing a program to provide the benefits on the right. Our label in the center is what you should look for when you're in the market for water-efficient products. To date, we estimate that more than 1 trillion gallons of water have been saved through the shipment of WaterSense labeled models, and consumers have saved $22 billion in water and energy bills through their use. Next slide, please. Even though the focus of the program is on labeling and certification, we employ a variety of methods to achieve our goals and help protect the nation's water supply. In shorthand, our program focuses on 3 Ps: products, practices, and people. Today, we are going to focus our attention on practices related to stormwater management. Next slide, please. For those of you who are new, this gives you a sense of our previous webinars. Each covered our 3 Ps in some shape or form, and each featured some great guest speakers. We've recorded all of them, and you can find links to them on the website listed at the bottom. And today we're going to be talking about green infrastructure. EPA has quite a few resources to support green infrastructure, including publications such as our WaterSense at Work Best Management Practices Guide and EPA's Enhancing Sustainable Communities with Green Infrastructure. We have various web-based resources. Check out GWiz, our self-guided online tool for local officials and community members to explore the wealth of EPA resources available to learn about and implement green infrastructure at the local level. EPA also provides technical assistance to communities across the country to support the implementation of green infrastructure practices nationwide. That program focuses on significant technical, regulatory, and institutional barriers to green infrastructure. Excuse me, and building community capacity by sharing lessons learned. Project types include local code and ordinance review, conceptual design, policy review, and modeling. There are also a few small grants that could support green infrastructure products, including our Urban Water Small Grants Program. Proposals are actually due next week, and our Environmental Justice Collaborative Problem Solving Grants. Applications for that grant are due mid-February. Today we are going to hear about some great on-the-ground examples of how green infrastructure is being used by HUD-related properties in California and Arizona. But before we dive into those presentations, I want to briefly review some green infrastructure basics. Next slide, please. Green infrastructure uses vegetation, soils, and natural processes to manage water and create healthier urban environments. At the scale of a city or county, green infrastructure refers to the patchwork of natural areas that provide habitat, flood protection, cleaner air, and cleaner water. At the scale of a neighborhood or building, green infrastructure refers to stormwater management systems that mimic nature by soaking up and storing water either for recharge, reuse, or both. Practices range from downspout disconnection to bioswales to land conservation. Next slide, please. As many of you may be aware, stormwater runoff is a major cause of water pollution in urban areas. When rain falls in undeveloped areas, the water is absorbed and filtered by soils and plants. When rain falls on our roofs, streets, and parking lots, however, the water cannot soak into the ground. In most urban areas, stormwater is drained through engineered collection systems and discharged into nearby water bodies. The stormwater carries trash, bacteria, heavy metals, and other pollutants from the urban landscape, degrading the quality of the receiving waters. Higher flows can also cause erosion and flooding in urban streams, damaging habitat, property, and infrastructure. Next slide, please. Green infrastructure reduces and treats stormwater at its source while delivering many other environmental, social, and economic benefits. In addition to improving water quality, green infrastructure can mitigate flood risks, recharge aquifers, augment local supplies, reduce the heat island effect. It can reduce energy consumption by shading building surfaces, lessening cooling and heating demands. It can improve air quality by reducing ground level ozone and absorbing particulate matter. It can sequester carbon. It can increase available open space, protecting wildlife habitat, preserving sensitive environmental areas, and creating recreational spaces. And it can even reduce the energy load of water infrastructure. A National Resource Defense Council report that found that in just the urbanized areas of Southern California and limited portions of the Bay Area, LAD could provide as much as 405,000 acre-feet of water per year by 2030, with a corresponding annual electricity savings of as much as 1.2 million megawatt hours and a reduction of as much as 535,000 metric tons of CO2. It's no wonder that more and more communities are investing in green infrastructure. Like all of you, I am very eager to hear about the projects of Tucson Water, City of Santa Monica, and Tree People. But before we hear from our first speaker, let's quickly turn the mic back to Laura to first take a quick poll question.
Thank you, Charlotte, for that great introduction to green infrastructure and setting the stage for our conversation today. Before we hear more about green infrastructure from our guest speakers, we'd like to get a sense of where folks are on the spectrum of including green infrastructure in their properties. So again, we'll give you a moment to answer the poll and then we'll share the results. So thanks for providing that information. It looks like a large majority of you are incorporating it already, almost 2/3. And a third of you need a little bit more information before deciding whether it's right for your property. So that's good to know. With that, I'd now like to introduce our first guest presenter, which is Daniel Ransom from Tucson Water. And Daniel?
Great, thank you very much. We're going to talk a little bit about rainwater harvesting and a rebate program here in Tucson Water. First slide, please. So we asked the question, why harvest rainwater? You know, a lot of us know that the benefits of the water, so we want to reduce potable water use, and we're calling it demand reduction. we want to reduce the dependency on drinking water, and here in Tucson, the average outdoor water use is about 27%. In the last few years, it's gone down from about 45% to 27%, so we're reducing the outdoor water use here in Tucson. And we know it's a pressure resource, and we talk about rainwater as being free. However, the water is free, but not the infrastructure. So we have to pay for the infrastructure on how we capture that water and what we do with it. We know that the water quality is excellent. Plants really love that water. So that's a great reason to use rainwater, because plants just do so much better after a rain. And one of the things we're finding here in Tucson Water, we do a lot of stormwater management with it, even on site with residential homes. A lot of our participants in our program are doing rainwater harvesting to reduce on-site flooding. They do have issues with flooding on their properties, and they incorporate different techniques to reduce that. And of course, anything that we keep on the property reduces the downstream flooding. Next slide, please. So our rainwater harvesting incentives rebate program was introduced in 2012. So it's been in place for a little over 3 years now. And as of July 1st, 2015, we did expand it a little bit to include curb cuts, core drilling in the right-of-way. And so that will allow customers that want to do the right-of-way next to their property, allow some of that street water to come into that area. However, they're not allowed to let that water enter their private property. The other thing we increased our program just recently was allowing small commercial, and that's I'll have a little bit of information on that later. So as of recently, we have approved 151 applications this fiscal year, and so it's up quite a bit. So you can see on the chart, since we started the program, so fiscal 13 up to now, you can see we're actually kind of ahead of those years with our rainwater harvesting. It's become very popular, and we've spent over $1 million in rebates to date. So it's a significant amount of money we've invested in this rebate program. And you can see the zeros for estimated gallons saved, and I'll talk about that a little bit later also. Next slide, please. So our rainwater harvesting program, who qualifies? It started out as single-family residential, expanded to small commercial, so they have to be a Tucson Water customer. And we define the small commercial property with a single meter that's either 5/8 or 3/4. So if they have 1 inch or larger meters, they're not considered small commercial. The idea is that small commercial has the same footprint as a residential property, so it might be somebody working out of their home or just a small commercial property. So one of the criteria to qualify for the rebate, applicants must attend an approved 3-hour workshop to qualify. And the workshop is free, and one of the things that we're finding out is 37% of applicants are attending the workshop after the system has been installed. And we want to kind of work on that, because the idea is to educate the installation of the system prior to installing it, so they get a better design, know the best management practices, and they get better systems. So we're going to try and work on that, and but we do not, or we allow them to install the system first and then take the workshop second. And part of the workshop too is that they learn about maintaining the system, so the systems aren't neglected and that they will continue working after they've been installed. So we have 2 levels of the rebate and applicants can apply for both a passive and active system. Passive, directing the water direct to the landscape and used right away, or active, installing tanks for later use. So they cannot exceed $2,000. So they can get up to $2,000 for the combination. Next slide, please. Level 1, again, simple, passive. The incentive is based at 50% of the cost of eligible materials and labor, and they can get up to $500 for that part of the rebate. For the level 2, which is the cisterns, the active, installing a tank, you can get up to $2,000, and we have two criteria. If you install a less than an 800-gallon tank, it's at 25 cents per gallon capacity, and if you install an 800-gallon tank or larger, you can get $1 per gallon capacity. The reason for this is to incentivize larger systems, and we know that as you install larger systems, the cost goes down on installation and on also the cost of the tank, so it's a little bit more cost effective. Next slide, please. When we started the program, we were looking at evaluation for effectiveness, and basically we had three criteria. We wanted to look at participation, especially the workshop participants of the applications and spatial distribution of those. And I'll have a map to show you how that's working out. When we first started the program, we had a great response, and we could not keep enough workshops going. We were running about 6 to 8 per month just to keep up with the amount of people wanting to attend. And second criteria, we're going to cost-benefit analysis to make sure that the program is beneficial and that there's a payback period. And third, water savings. And again, we're looking at a demand reduction with the water savings to kind of see if people are going to really save on their water bill. Next slide, please. So here's that first map. It does include our gray water program also in the white dots, but you can see the blue dots in this map show the installations of all our rainwater harvesting applicants, and you can see we've had nearly 1,000 applications approved. Our average rebate is $1,250. We do a lot of rebates that are actually the full 2,000. People install very large tank systems and receive the full rebate. And you can see about 15% of them are level 1, which we call the passive systems, and about 85% of the customers are installing tanks. However, we know a lot of those tank installations do have a combination of both level 1 and level 2, which is what we recommend, that they both have passive and along with their tank systems. So another fact is that 29% of the workshop participants have received a rebate, and so we are getting a good turnout for participants after they do take the workshop. But when you look at the map here, you can see up in the kind of northern part of the map is where most of the blue dots are, and as you can see, as we kind of go south, we're not getting a lot of participants, and that's kind of where the low-income families are, south of those. And so that's one of the things that we're trying to do, is look at how we can get more low-income participants and how we can help them participate in the program. Next slide, please. This map kind of gives you an idea of where those low-income families are located, and you can kind of see it helps us determine where these low-income families, and you can kind of see that where the previous map, a lot of the participants are up in the upper part of the map, and where we're really trying to get the low-income families to participate are in that southern part of Tucson. So that kind of just helps us give an idea of where we need to concentrate and target the low-income program, which I'll be talking about a little bit later. Next slide, please. This map is a shade tree map, in which you can see is there is a correlation between the low income areas of Tucson and the lack of tree cover. So it gives us a really good indication of when we're trying to do the urban heat island and get more trees planted. Those are some of the areas that we also want to target, and they do fall within those low income areas. So that's where we're trying to work at, both getting more trees planted and incorporate rainwater harvesting techniques. Next slide, please. We did a simple payback, and one of the things that we're looking at is what is the cost effectiveness of these programs. And so based on the water cost, and that's at $4.96 per thousand gallons, that includes the cost, the taxes, the price for cap water, conservation fee, gives us an idea of what the water costs, and then we apply it to a 50-gallon rain barrel, and if it fills up 5 times on average, you're going to get about a $1.25 value based for annually on just a rain barrel. So that's why we try and incentivize larger tanks, because they'll be able to capture more water. And you can see 865-gallon tank, 2145 value annually, and the 2,825 gallon cistern filled 5 times can collect, you can see, much more water, and then has a little bit more value based on those rates. However, when you do a payback, you're looking at, with a rain barrel, maybe 80 plus year payback, so it's not very cost effective, especially when you have to add gutter to the cost of those systems. Then you get into the larger tanks. The gutter, the cost of the tanks goes quite a bit down in the payback. It's still a pretty extensive payback when you have a 60-plus year. Next slide. So we wanted to include this water savings. This is a low-income HET program, and this just kind of gives us an indication of a successful program when we start evaluating the effectiveness of these programs. And you can see in 2011, this group of participants is when they changed out their toilets, and you can see the previous couple years, just by the blue line, you see the participants are much, much higher than all single family. So the red line is just the average of all single family homes. Then after installation, you can see that that participant line has dropped significantly and kind of stayed below all single families. So this is what we like to see in our programs, that we know that after we, in this case, changed out the toilets, we did receive savings, and there was a very good program with good results. Next slide, please. This is the 2012 participant analysis, and one of the things with the rainwater harvesting program still being fairly new, we don't have a lot of water history yet, but this is the first participants in 2012, and you can see in the center of that graph where the change outs for the systems were installed. You can see the history before. This slide is showing all single family in the purple, so it's an average of all single family in Tucson, and you can see they're pretty low water users. And then we used a high use control group to compare them to, and the same customer is the rainwater harvesting participants. And the reason we're using same customers, because even those customers or applicants that have stayed in the home and are still living there, so we can track the water use. But you can see when we compare it to the high use control group, that they are, a lot of the rainwater harvesting participants so far have been very high water users, and significantly higher than the average Tucson customer that we see in all single family. So we're really not seeing a lot of reductions in water use from this program. Next slide, please. This is the 2013 participant analysis, and as you can see, we do have the next group of participants, and you can kind of see about the same results. They're significantly higher than the average single-family home. They're even higher than the high-use control group that we're using to compare. And when we're talking about high water use, a lot of these customers are using 40, 60, maybe even 80 CCF per month when we're looking at some of their water use, especially in the summer. So they're very high water users. And one of the things that we're looking at is we may not be seeing a lot of savings because their water use is so high that if they do reduce their water use by a couple CCF, each 748 gallons, they will not show up very much because they're such high water users. Next slide, please. Okay, so what we're trying to do is see how we can incorporate low-income families into our rainwater harvesting program, because you could see as the previous map, we just weren't getting a lot of participants in the low income. So we partnered up with Sonoran Environmental Research Institute, and they are a nonprofit organization that already works with low-income communities, so they were a really perfect fit to help us work on this. They received a grant for $20,000, and we matched that with another $20,000 and started installing some rainwater harvesting systems in a target area. So some of the criteria for this program was they had to have trees from Trees for Tucson. Trees for Tucson is a partnership with the city and our Tucson Electric Power group that provides trees for $8 each, so you can't beat that for purchasing trees. They have to install them in the right location so they will shade the home and help reduce energy. We make sure that they are a low-income family. But the difference between this program and the other rebate program that we offer is they also have to attend a rainwater harvesting workshop, but also they will attend a tree care workshop. And that's so that they can take care of their trees and understand how to water them and maintain. They do need to allow access to the water use history, and so we can track their water use and then also monitor and photograph the system. But also, which is important, is we want to get buy-in so they really are going to maintain the system after they install it. So make sure that everything is taken care of, because we want to make sure that the trees that they have are going to survive. Next slide, please. Some of the community concerns that we've found out working with low-income groups is a lot of them are worried about mosquitoes, and one of the things is if you find a lot of rain barrels out there that people are using trash cans and other things for collecting water, and one of the requirements of our program is that they need to be sealed tanks, whether it's a rain barrel or a large tank, and should not have any way for mosquitoes to enter that barrel or cistern. They want rain barrels and gutters. They do not understand, or really are not knowledgeable about earthworks, and so they're not familiar with passive systems, and they don't recognize it as a rainwater harvesting technique. So that's where the education component comes in, so they can really learn about these other rainwater harvesting techniques and how to incorporate them into their properties. A lot of them do not have funds to participate in the rebate program, and they think that it will cost a lot of money to water the trees, and that's important because with the education of tree care, we can educate them on how much water it actually takes, and it really doesn't cost as much as they think it does to maintain those trees. Additionally, discussions with families have indicated that they just do not understand drought-tolerant trees. They do not know how to plant them correctly. They do not understand the watering. They do not know that mulch really improves the retention of moisture, and again, rainwater harvesting general maintenance. So with the workshops incorporated, this really helps to educate this low-income families on the tree care and installing these systems and maintaining them. Next slide, please. So next steps, when we're finding out that low-income properties don't feel that they can afford to participate in the program, whether they don't necessarily know if they can borrow the money or pay it back, we are working on a pilot with Siri has received a grant to work on a revolving loan program for low-income families, and it was specifically for rainwater harvesting. For this pilot, they're going to pilot 10 families in this pilot to determine how that works. And talking to the low-income community, they have developed this program. They're offering a no-interest loan for installing rainwater harvesting systems, and they have found from the initial discussion from running focus groups that families feel that they can borrow up to about $100 to $400 worth of loans and be comfortable with that, and make the payments up to $40 per month for a $400 loan. And you can see they're going to be offering short-term loans, 6 to 9 months. And if they don't pay the money back, they would incur a 5% interest on the loan. But so this is going to be a way to help low-income families participate in the program. So from there, if they install a passive rainwater harvesting system, say they take out a $400 loan, that rebate would offer $200, and that $200 can go back to paying off that loan. Next slide, please. So conclusions for the rainwater harvesting program. We're finding that rainwater harvesting rebate is not shown to be effective as a demand management strategy. However, we do realize that there are other benefits. But one of the things that we have noticed that a lot of the users, even though they didn't show on that graph that earlier, is these users are very low water users, and so they're not there's not a lot of room for water savings. And then we have the other customers that you saw in the graph, where customers are price inelastic and they care more about the landscape than the water bill. And that's what I think we're seeing, is we have these very large rainwater harvesting applicants, customers that have either expansive landscapes, or when they installed the rainwater harvesting system, they actually increased their landscape, might even have fruit trees, gardens, things like that. So if demand reduction is a goal, it needs to be communicated and incentivized, and we're kind of working on how to get better reduction in potable water use on our program, either by education or through more intervention. We want to make sure that policies are consistent throughout the jurisdiction, and we realize that rainwater harvesting green infrastructure is an important tool in addressing stormwater and climate change concerns, especially as we try to increase tree canopy in these areas. And so conduct a needs assessment to identify the scope of the problem and develop policies and budgets and establish a sound funding mechanism. And so that's kind of where we're looking at to increase tree canopy, incorporate rainwater harvesting, and utilize curb cuts, even to utilize that stormwater runoff of the streets to help water some of these trees and help with the increase in tree canopy. Next slide, please. And that's it. Thank you very much.
Thank you, Daniel, for sharing those experiences with implementing the rainwater harvesting rebate programs at Tucson Water. Those were some interesting findings and conclusions. And next up, we have Neil Shapiro with City of Santa Monica. Neil?
Good morning, good afternoon to everyone. Glad to be here and share information about our City of Santa Monica's program. Next. So I'll give a brief introduction about our program, talk about two specific projects amongst many projects that we have, and then have some conclusions. Next. Next slide, the introduction. So for those of you not familiar with Santa Monica, we're on the Santa Monica Bay. We're surrounded on all three sides by the city of Los Angeles, nestled there on the Pacific Ocean in Santa Monica Bay. Next. And as Charlotte had mentioned earlier, urban runoff is a major problem in terms of water quality. It's the single largest source of water pollution in the country, and there's been lots of studies, and I'm sure most of you are familiar with that. Next. And as Charlotte also showed a similar graphic on the bottom left, when we start paving over our landscapes, putting in homes and roofs and parking lots, we disrupt that to get more runoff, and that carries a bunch of pollution, and we get impacts to our surface water bodies. So in Santa Monica, we want to try and get back to working with the water cycle. Next. So in terms of managing stormwater in Southern California, and probably around the country. Generally, there's been a hierarchy of solutions. At the bottom there, you have detention. That has been the most common solution, where you just collect the stormwater or rainwater, let it settle for a little bit, let it drop out sediments and some pollutants attached to it, and then you release that water back into the surface water system. And then we had a lot of different proprietary products come in online that would filter and screen and separate pollutants from the water but still release it, and then would filter soluble pollutants out of it. And then we started transitioning into more sustainable on-site treat and keep on-site solutions, so through biofiltration and then surface infiltration, and then ultimately to rainwater harvesting and on-site beneficial use of the water resource. So that's been the progression in Santa Monica since the 90s. We've now gotten to the point where we're really focusing on keeping the water on site and using it for beneficial purposes. And also, the driver has always been regulations with the stormwater permit, MPDS, in terms of water quality regulations and compliance. But we found that the solutions we keep coming up with to solve the water quality problems actually help us with our water supply issues. So obviously in Southern California, we do have a lot of cycles of drought, and so whatever we can do to harvest rainwater, keep it on site, and develop a local water resource, that's a big advantage. So the solutions we focus on actually help us with our water supply and also help us comply with the water quality. So one solution, a dynamic solution that solves two particular problems. Next. So again, in our city, our management focus is on converting as much impermeable, making it permeable, storing any kind of rain or dry weather runoff on site. And as Daniel mentioned, we have passive and active solutions or direct use solutions, and really try and focus on becoming self-sufficient. And in our city, we do have a 2020 water self-sufficiency plan, so hopefully by that year we will have developed our local water resources so that we do not have to use imported water. Next. And we have a variety of tools like most cities around the country, and so I'll briefly describe some of our ordinances and two particular treatment projects going forward. Next. So we have a number of ordinances. The first one mentioned there is our urban runoff pollution mitigation. So whenever someone builds a new project, a new building, or redevelops their building, they are required to have a post-construction best management practice, some sort of structural device to harvest the rain and keep it on site. And we have two parcel fees that we have that help fund our programs in terms of building city projects to do this, or maintaining the various BMPs, LID kinds of projects that we have around the city. And in addition to that, as Daniel mentioned, we do have a rebate incentive program. So if you want to retrofit your property, you can put in rain barrels, redirect your downspouts, put in cisterns, and also do rain and rock gardens. So we have rebates of up to $2,000 for the various types of BMPs of that sort. Next. So now let me go on and talk about one of the two projects. Next. So our Green Beach parking lot. So in our city, we're a built-out city, so we can't add new open spaces in terms of new land. So what we want to look at is where are there opportunities to actually create more recreational open spaces within the city. So we do have a lot of beach parking lots, and some of our management thought it might be a nice idea to try and convert a parking lot to have more recreational benefits in addition to having a stormwater management component. So we got a state grant, and we converted this particular parking lot, which is in our southern border. It's only used about 4 or 5 times a year for overflow parking or for major holiday weekends. So this was converted for this particular project. Next. So this shows an aerial of what we were going to do. We're going to remove about 1/3 or more of the asphalt and put in a grassy structural product called net lawn, where you could actually park on it, but also use it for recreational activities. Next. And this is a cross-section of what this particular product looks like. So it has a sand base, and it also, you mix in these plastic rectangular pieces, which I'll show a picture of, and these plastic pieces are compacted down, and then they kind of interlock and forms a structural base in which you can park your car on it. Next. So there are a lot of other pictures just to show the construction, but I thought this would be most important just to see. You can see those plastic polyethylene pieces that are being woven into the sand matrix base. Kind of an interesting machine doing that. Next. So after that was done, we laid down some sod, and then we had our opening day event. So this is just showing the opening day event, some speeches, but you can see the right pictures. You can see the existing asphalt parking lot and then the new open space parking recreational area in the background there. And then any of the stormwater that falls in the parking lot flows into that new landscaped area and infiltrates into it. In addition, there's a roadway in the foreground that goes by there, and runoff from there also gets into the parking lot and goes to the grassy area. Now, we did want to actually put a cistern in there to collect the water to water the new turf, but we did not get enough money from the grant to do that. So one of the challenges in creating a new open space in semi-arid areas is that you're creating new landscape that requires additional water when you're trying to cut back on water. So we always try and balance that. We do want more recreational area, but we understand it may require more water, so we have to be very cognizant of that and look for strategies. Next. And the next picture shows just how it's used, when it's not being used for parking. They do play soccer on it, they yoga, other kinds of activities. Next. And then, of course, we also open it up for parking on those days when we have big holiday weekends or big events. So when we do have parking on it, we have a lot of city staff there to check what's going on and make sure people aren't walking when we're supposed to be driving, so we avoid any accidents. And that was a liability challenge to us on how to make sure that people don't get injured. Next. And then this is what it looks like today. Next slide, please. Our second project is our Virginia Avenue Park. We built a new library a year and a half ago. Next. And so in building the library, we wanted to see about collecting the rainwater from the roof and actually using it directly, not for irrigation, but for actually indoor flushing, which would be a first project in our city, perhaps in the region, because using the rainwater for outdoor use is kind of it's a pretty simple thing. There's no public health issues, generally speaking, when it's used for subsurface irrigation. More so, there's challenges with spray. But using it indoors has been a challenge for our public health officials, building officials, because it's not generally something that we do, an alternate water supply, and we certainly want to make sure that we protect the public health in terms of the proper treatment and make sure that during the flushing process no one's going to be exposed to any kinds of pollutants that might cause problems. So we were able to get the project approved through our building safety people and through LA County Public Health, who worked very closely on the project. This slide on the top left shows the pre-treatment system where the water comes in on the left and it goes, the water comes in on the right and goes in that screened area, swirls around, all the trash and debris goes down the center, and then the water goes through the screen and exits out through the pipe on the left. Picture on the right shows the installation. Picture on the right and the bottom center shows a picture of installing a perforated concrete system, a Maxwell deep well system, like 30 feet deep. So when the cistern fills up, it overflows into this structure, and we can actually infiltrate additional water into the ground. Next, please. This is the installation of the 12,000-gallon cistern. It's going under a fire access road, and then in the background you can see the new library building and the roof that will be draining to the cistern. Next, please. So here's the final installation. Everything's done, and here's some of our installer of our harvesting treatment system. They've removed some of the covers and looking inside. So there's 3 covers to get access to the cistern. The top right picture shows looking into the cistern. It's filled up, and it actually has a pump that pumps water in bubble action a couple times a day to prevent any mosquito vector problems. And then bottom right shows the pumps that take the water to our treatment system, and the bottom left actually just shows a shot of the cistern when it was getting near the end of its water supply. Next, please. Then the water is pumped to our treatment system, which is about 30, 40 feet away in a locked, caged area. So the top left The water comes into the short, stout, round sand filter, and from there it then goes into the right, taller, thinner barrel-shaped device. That's our microfiltration. There's 4 cartridges that filter the water. Top right picture in the front there, in front of the 2 blue barrels, is the yellow UV disinfection system. And then the bottom picture in the background against the wall, horizontal pipe, there's a little horizontal kind of T-looking object. That's actually our backup and our residual copper disinfection. So when the water leaves the system, it gets the copper ions. So while it's traveling through the distribution line, there's additional disinfection for the water as it sits in the pipes. Next, please. And then the water, after it's treated, it goes into a 300-gallon day tank. So that water is readily accessible for flushing during the day. Right picture just shows the pump and actuary to move the water into the library for flushing. And then to the left of that round white device is our backup potable. So if we run out of water in the cistern, then that triggers a pump to open up and let the potable water flow into the system until we get more rain. Next, please. And then last week we started installing our educational signage for our rain harvesting system so that people actually know what's going on there. So we actually installed a footprint painting of what's there. So you can actually see the footprint of the cistern, their spray painted outline, and then there's wording there that says collected rainwater below here. So very excited to get that in so people actually know what's going on. Next. And then we'll be installing a large sign on that same road so that people walking by will actually see a schematic of what it looks like and explains the whole problem. There'll be a lot of statistics about how much water can be saved, what % of reduction we can expect from using potable water, and then show some other pictures there. Next, please. There's also, so in conclusion, this is just a small sample of the many hundreds of projects that we have around the city. That's both private and public projects around the city. So again, our focus is very much on getting the water back into the ground. There's information about the 2 projects I just spoke about on our website, which I'll show you shortly. But we do these kinds of low-impact development sheets about our major projects. So again, we combine passive systems, active systems. We're really focused now on the active systems because of the drought and looking to become more self-sufficient rather than infiltrating the water in the ground, since our aquifers are actually pretty deep and not really accessible. Next, please. And this is the contact information if you want to get in touch with me, phone number, email, and there's the website that has a bunch of information about all the projects that we've done and lots of other information about how you have to comply with our ordinance. And thank you very much for EPA and HUD inviting me to speak and share information about the city. Thank you very much.
Thank you, Neil, for that insight into Santa Monica's green infrastructure strategy and those example projects. It was really nice to see photos and get a taste of that. And I realize that we're getting short on time, but I really encourage everyone to please stick around for our last speaker, Andy Lipkiss of Tree People, and also for our Q&A. So without further ado, I would like to introduce Andy, founder and president of Tree People.
Thanks, and good morning, good afternoon, everybody. I realize we are short, so let me just jump straight in and say the work that we're doing is focusing on how to take green infrastructure to scale on private property and on public lands. The previous speakers have referred to the need to move from projects up to programmatic funding in order to start getting cost-effective impacts, and also to move beyond the single purpose of water supply. And so what I want to do is show a quick video that'll ground you in how we have been doing this work in neighborhoods, and it can go to large HUD projects, housing projects in and of themselves, or integrate into neighborhoods and private properties. I just want to, before we run this, want to acknowledge that what you're going to see is the result of a collaboration with a whole lot of cities, from City of Los Angeles and City of Santa Monica and the County of LA. The project was actually run by LA's Council for Watershed Health with Tree People and funding from agencies. You'll see it at the very end of the video. The collaboration of exchanging, trying these techniques and improving, sharing our learning, sharing our failures is between Seattle, Santa Monica, Los Angeles, and other cities. And the work always includes really deep community engagement to educate and enroll the people who live there, the stakeholders, so they're part of the process and ideally even part of the maintenance. So without further ado, why don't we roll the video?
We are right here in LA's San Fernando Valley in the Sun Valley watershed at the corner of Elmer Avenue and Stagg Street, because this is a community that solved a massive flooding problem, pollution problem, and drought problem, the kinds of things all communities are facing with climate change, from working together in a really unusual way, where neighbors got together with nonprofits and government agencies led by the Los Angeles and San Gabriel Rivers Watershed Council and planned together a solution that saved money, created jobs, and created sustainability. This was the epicenter of a regional flooding situation. Water flowed from 40 acres north of us and came through down here, making it really hazardous for this neighborhood. Sometimes water so deep that people couldn't safely get in and out of their homes to the street. The water was polluted by oils and toxins that it had picked up throughout the neighborhood. And then it would flow on down, polluting the LA River and on down to the beaches.
When it rains, the whole street was flooded.
And it was pretty much a dangerous situation with the children trying to cross over the water and just trying to get to school from here.
The solution we deployed included two major strategies. One was to pick up the floodwater that was flowing from over here, put it into a catch basin right here, and take it underground to the street that was ripped up, and we installed a huge infiltration gallery. That's two large pipes loaded with holes. The water flows through, the water comes out the pipe into gravel and then down into the aquifer, the region's water table. The result is a healthier street, and this process significantly saves money in the long run because it makes the street part of the whole city's water system. The second strategy was to address all the homes on the street, to capture all the water that they were contributing to the flood and capture it, clean it, sink it back in the ground. Before retrofitting houses, when rain comes down, it is directed into the driveway, which causes flooding. That water picks up waste and adds to the contaminants in the neighborhood streets, which then pollutes our rivers, beaches, and ocean. With the retrofitting of homes, now when the rain falls, the water is carried by the roof rain gutters and then redirected into a cistern or rain barrel. And if that water overflows, it soaks into a sponge-like, water-efficient rain garden that replaces grass lawns. If there's overflow from the garden, the water moves into permeable driveways, walks, and other surfaces. Or the water is captured by a driveway trench drain, which conveys it to a swale. A swale is a creek-shaped structure consisting of rocks, mulch, climate-appropriate plants that all work together. The swale collects and cleans any overflow from the paved surfaces. And trees are planted around the swale along with the plants and mulch. And the tree does what trees do everywhere. It's the big sponge to put the water underground. Once a swale is filled to its capacity, the water flows out onto the street, and it comes in to this curb cut and on into the swale, where it encounters the rocks, the mulch, the roots, and the plants, where it's slowed, it's filtered, and slowly infiltrated into the groundwater. Anything that overflows comes on out this curb cut back into the street and flows down to the next curb cut, where it joins other rainwater that has fallen onto the street and flows into and is absorbed by the swales further down the block.
In this way, we can save money in the long run because we're putting the water back into the ground instead of sending it out to the ocean.
It's been kind of an ecological change as well. We see a lot of different birds here now.
All these components work together as a whole system that mimics a natural watershed. To accomplish this, we built a partnership with nature that included the unique cooperation of nonprofit organizations and a variety of government agencies who in this case are concerned with water conservation. And all of them work together with the people on the street.
One of the things that the residents requested were street lights, and so we found a way to incorporate these pretty innovative solar street lights that you can see a solar panel up there. They capture the sun during the day and have great radiation, the same as the ones that are on the grid at the city, but these are completely off the grid. They're not connected to anything, and so they don't take any power.
Tree people, they came and talked to us, and we had a day where everybody helped pitch in and do the tree planting, and we all worked together.
The project in general took about 5 years, but it's really brought back a sense of community here to Elmer Avenue.
So if we want to give me screen control,
Sure. One moment.
Throw together a couple pictures. Let's see if it works. My screen. You guys up?
Yep.
Can you see?
Yep, we can see your screen
go
now.
into slideshow mode and see if that works. And do you see my ID?
We see kind of we see two slides at once. It's not in full presentation mode right now.
Huh.
But
so are you seeing now a bunch of dots?
yep, it's okay. This is fine. It's not full screen, but it's fine.
Cool. So I just want to jump to how do you pay for this? We talked about green infrastructure does more than water supply. It's flood protection, water quality, water supply, energy conservation, even managing green waste and biomass as you start to incorporate it into your treatment train. And the challenge is all these different systems are now different government agencies with different budgets. And green infrastructure addresses all of them. And the challenge we face is how do we actually bring them together so they can co-fund green infrastructure projects? Because as our first speaker pointed out, the payback for simply water, it doesn't work. And there's so much of a payback when you incorporate many more of the aspects, including right at the core, getting economic development. So that's been our goal in bringing together multiple partners. We've been able to have them co-fund projects. We use a cost-benefit modeling tool that basically shows how you can assemble various green infrastructure best management practices, scale them, and apply them, and get major savings back. And I don't have time to go into that, but that tool is actually being renovated and will be an online tool, and it's been really successful in helping us bring together very large partnerships to pay for this work. So I know we are out of time. I'll give it back to the facilitator to decide whether we're jumping to questions or where you want to go with this. I actually have a 12 o'clock meeting that I'm going to sit this out, stay with you for a few more minutes.
Okay, thanks, Andy. So I guess we should go ahead and move into our Q&A portion. Thanks for everyone who is sticking around. And Charlotte is going to be moderating our Q&A. Do we have any questions for Andy that we can get off the bat?
Yeah, thank you, Andy, and everyone for sticking around. There's two questions for you, Andy. One is that will there be a link that you can provide for the tool that you guys have been developing?
Yeah, once it becomes available, we're working with partners with County of Los Angeles, City of Los Angeles to bring it up. Right now, it's a desktop tool, and we don't. If you want to get in touch, we can send you a PowerPoint show on how it works. But
okay.
it'll be much better later.
And then the next question for you specifically is, how did you get Public Works to be comfortable with so much infiltration under the roadway? In Tennessee, for example, no infiltration is allowed for fear of road failure.
So this project was actually built by our city's street division. We have worked this field now for 22 years and brought together major engineering firms, the cities, to work on strategies and test them so they're comfortable. So they completely rebuilt the road, needed to in this case because of its failure. And I think that that's a really important both opportunity, resource, and strategy to look at. Today, Los Angeles has, as many cities, but in the city of Los Angeles itself, due to deferred maintenance because of the economy, lack of investment, we have failing roads. And the city has proposed a $4 billion emergency project just to take the worst failing roads and rebuild them so they can last. But when you do that, essentially we should see that, first of all, roads should never be built the same way when you are in a drought-stressed, when we're entering this new period of severe climate, when you're going to want to be capturing that water, treating it, not just getting rid of it in a dry environment. So it's an opportunity to really relook at the whole system and say, what do we do? The need for cooling cities, because of in some areas like Southwest Los Angeles, we have severe urban heat island and now increasing human mortality because of severe heat. And we're going to need to follow the successful path of Australia in creating dense tree canopy to shade the city, and they've set a goal of 40% tree cover in order to save human lives during their severe heat. Well, you've got to rebuild infrastructure for making sure there's sufficient water, and rainwater can do that to supply the trees so they can do their evaporative cooling. So I'm basically speaking here to really working towards a full integrated approach. And in doing that, we begin to find lots of resources. I'll point to the fact that the White House and the EPA have launched the Green Infrastructure Collaborative. We're part of it, as are other cities. It's working on just this and helping federal agencies begin to integrate how they support major investments in local areas and support local cities in pulling together multiple infrastructure agencies to be able to create a programmatic approach to building the green infrastructure.
Okay, and then people have a lot of specific questions about Elmer Avenue, and I'm wondering if there is a document that either Tree People or maybe the Council for Watershed Health put together summarizing that project, how it was funded.
Yeah, the Council for Watershed Health should have it. So it is the Council for Watershed Health. You can go to their website. I'll look to see if I can get you more links. One comment I wanted to give you on it is that this was a research project to, in fact, show both how the infrastructure could work, but even more importantly, what is the relationship with people, the depth of stakeholder involvement in planning and having homes choose whether people choose whether they want to participate or not. This was funded 100% for the participants, so they didn't have to put up money. After the water costs returned to them, not all of them put in rain barrels, and so some of them were concerned about the costs. But one of the things the approach they were researching here is, can sufficient education and engagement, could that be sufficient to do all the maintenance that's needed? And the answer is really no. Green infrastructure is functioning infrastructure, and for it to function fully and be beautiful, but also be bioremediating and all that, you really do need to have trained, certified maintenance people, part of the system, part of your workforce, and funded to monitor, maintain, and help spark volunteer activities of your homeowners and residents. And that's, as you saw that flower chart earlier, jobs being one of the core benefits to economic development. When we do this, Tree People has always intended to see this work generate high-quality jobs in communities. And you can track us for our strategies for how we're making that happen. Thank you.
Yeah, thanks. And Andy, you can answer this question too if you have time, but it's directed toward everyone.
I do need to run, so I'm gonna. I've got my meeting waiting for me. I'm sorry.
All right. Well, thanks.
Thank you,
for sticking around.
everyone. And, you've got our contact information. So, and by the way, on this slide, you can see there's the Miracle on Elmer Avenue is the name. It's available for you on YouTube. And another, the prequel to that one is Capture the Rain and Rebuild the Economy, that talks about the collaboration with the agencies. So thanks very much. Sorry I have to run.
Thank you. All right, so Daniel and Neil, if you have some time to stick around, there's just a couple, I think, really great questions here. One of them is about, cities like yours that have programs in place to support, green infrastructure and stormwater harvesting. Do you sort of keep good tracks on metrics for those projects' impacts? Have you measured increases in groundwater recharge? Have you measured the decreased burden to stormwater systems, flood events? And how have those metrics, helped to support your programs?
This is Daniel, Tucson Water. We are just starting some of that, and especially with our rainwater harvesting program. We usually run a program for 3 years, and then we start to evaluate it. So we are still working on that kind of information. We do have some studies about areas where we're working at mitigating flood control, and we will be studying that a little bit more. So we're just kind of getting started on coming up with that kind of information.
Charlotte, are you still there?
Sorry, I was on mute. It looks like we've lost Neil, but I wanted to just ask one more question of Daniel, which is who installs the rainwater harvesting? Is it the onus on the homeowner to select the contractor, or does Tucson Water take care of the installation?
Yeah, good question. With our rebate program, we allow the customer to install the system themselves or hire a licensed contractor. So it's up to them to do that. We know that the customers that are go to the workshop, get educated, they can save quite a bit of money by doing installations themselves. And then also the ones doing the passive systems, we know that it's just kind of backbreaking work, and you can do that. A lot of passive systems with not spending a lot of money, just materials. So we allow both.
Great. And another excellent question was, and I think you started to touch on this at the end of your presentation, which is, have you thought about adding a water reduction requirement to the rebate? So if you were to associate a tiered incentive that relates to the amount of reduction.
Right. With our evaluation, we'll be looking at things like that, because what we want to try and do is make sure that the program does reduce water use. And so as we collect more information, just kind of like, what are the participants doing? Are they installing? What are they watering? Are they adding to their landscape? Things like that, so we can kind of evaluate the program and improve it. So we will be looking at all that and trying to get more information, including surveying our customers to find out what they're installing and how is it working out for them.
And Neil, I see that you're still on the call. You want to try speaking up again? No? Okay, well, there were a lot of questions for Neil, and we're having some technical difficulties and can't, hear him, but we will follow up with those questions with him and Andy and Daniel. And now, given that we are now fully 17 minutes past, we just want to jump into the, the very last part of our presentation, which is another poll question.
Another poll. Yeah, thank you guys again for sticking around and showing your dedication to learning about green infrastructure. And so we're curious if you like these webinars, should WaterSense and HUD continue to work together to have more webinars in the future?
Neil's back if you can hear me.
We can hear you now, Neil.
I redialed.
Oh, interesting. Unfortunately, I guess since we're so past time, we're just going to try to follow up with questions separately, if that's okay.
Okay, I started to answer the question about the metrics. I mean, we do have a lot of metrics on our projects, but not specifically about groundwater recharge and water use reduction.
Okay, good to know. So it looks like we should pretty resoundingly have more webinars, but it also depends on what we plan to cover. And so this is the last webinar of our HUD Water Wednesday webinars for the year scheduled. And so we are open to holding additional ones. And so if there's a subject we haven't covered yet on a webinar that you'd like to hear more about, please email watersense@epa.gov with your ideas. And do remember that all of our previous webinars are recorded and available on the EPA website. And we are specifically looking for strategies that will help affordable housing managers use water more sustainably. That's kind of the mission of these HUD Water Wednesday webinars. And if you can't wait until, next year for another webinar series, you can check out an upcoming green infrastructure webinar focused next month, excuse me. And to find out about EPA updates on green infrastructure, including publications, training, and funding opportunities, you can join our Green Stream listserv, which is shown here. So just send an email to that email list to join. And a reminder that HUD has set up a Water Watch forum on their Switchboard platform, and the link is provided here. We encourage you to check it out and provide your feedback. And finally, here are some helpful links for you for WaterSense. Again, that HUD webinar page. You also might be interested in our best management practices, which you can find on the URL shown here. If you have any questions, please feel free to email watersense@epa.gov. And I know our panelists also kindly provided their email addresses as well. So thank you again for joining us. Look for the recording and slides of this webinar to be put on the WaterSense website, and enjoy the rest of your day. And thank you again to our great speakers and everyone for joining us.
Thank you, Laura. Thank you, Charlotte. Thank you, Daniel. Bye, everyone.
Yeah, thank you.
Thanks. Bye.